Okay, this video is going to be for compound interest. It's one of the three short videos that I'm going to do with finances, so I'll do it today and tomorrow. So this one will be the only one today. Keep it easy. So, compound interest is when you get interest on an investment, and every period that you get the interest, you get interest on your interest in addition to your original amount. So, what does that mean? If I take a look at something we've looked at before, simple interest, like in this problem, if I invest $1,000 at 4% interest for 5 years, if with simple interest you simply get 4% of the original amount, the $1,000. So at the beginning, in year 0, you would have $1,000. After 1 year, you would get, at the end of the first year, you get $1,040. At the end of the second year, you would get $1,080, so another $40, which is 4% of 1,000. Year 3, you would get 1,120. Year 4, you would get 1,160, and the end of the 5th year, it's 1,200. Notice that there's 6 periods here. It's because you start at the beginning of year 1 and you end at the end of the 5th year. So the end of the 5th year is like the beginning of the 6th year. So you actually have 6 periods here. For compounding, you're actually getting interest on the amount you've accumulated. So after 1 year, well, you still have the same, 4% of $1,000. But the end of the year 2, you get an additional, you get 4% of interest on the 1,040. So if you do that, you would get 1,081 and 60 cents. In year 3, you would get 1,124 and 86. In year 4, you get a little more. You get 1,169.86. And year 5, you would end up with a grand total of 1,216.65. So an additional $16.65. You could have also just used our handy geometric sequence formula, because what you're doing to get from one to the other is, like we've done before, multiplying to get from one term to the other. So we've done those before. If you're compounding monthly, or like many times in 1 year, quarterly or whatever, the problem becomes a little more interesting. So if you're compounding monthly, it means you're getting the interest every month, but you're not getting 4% interest every month. That would be crazy. What you get for monthly is your interest rate would actually not be 4%, but in a month, it would only be a fraction of that, which would be 1/3 of 1%. Okay? So that's what you're working with. If you get that every month, you end up with the equivalent of 4% a year. You actually get a little bit more because you're getting interest on that previous interest, and it's happening during the year. So in this case, I wouldn't go through a list of year 0, year 1, year 2, year 3, year 4, because how many times am I going to calculate this, right? I'm going to calculate the interest 12 times a year for 5 years. So that would mean that I would have 60 calculations to make. So I would go straight with my formula. UN equals U1 R to the n minus 1 to get to my answer. I would have done it in part B also. So what do I know here? Well, I know the initial amount is 1,000. I know my rate is 100% plus 0.33%. I'm trying not to round off, so I'm going to keep that little 3333333. Now, how many times do I make this calculation? Well, n's going to be 12 times 5, 60. Plus 1, because you're starting from 0, remember that. So 61. So if I do that calculation, it's going to be 1,000 times 1.003 raised to the power of 61 minus 1. Oops. Right? Because that's in the formula. So I get 1220.996, so I'm going to round off 1221. So I get an extra $21 over simple interest, an additional $4.35 over compounded yearly. So you get a little bit more. So that's what compounding is. Okay? Now, in the IB, they don't actually use this formula for compounding. Or you can, but they give you a separate formula. So let's take a look at that. Here it is, and it is indeed the same as the geometric sequence formula. They just change the terms. So in finances, for the value that you have now, they call it the future value. For the initial amount you start off with, they have what's called present value. Now this is in your formula booklet, so you don't have to memorize these things. For the rate, for R, they have this whole thing is your rate. So what does that mean? So they change the letters here a little bit, so it might be confusing. So if we take a look at that, dig into this a little bit. R is the rate in percentage. So if we go back to the problem above, our example, this would actually just be 4%. Not 0.00, 0.04, just 4. Because they do the division by 100 in the formula. K is how many compounding periods you have per year. So for us it'd be 12. So if K equals 12, if they say monthly in their problem, K equals 52 if they say weekly, because there's 52 weeks. K equals 4 if it's quarterly, etc., etc. Okay? And then up in the exponent, you see that K is still the same, so you still have the same K there, and N is equal to the number of years. So they do the 12 times in our problem above. Here would have been 12 times 5, 60 would have been the exponent. Now you might say, isn't there that plus 1 because you start from 0? But remember, in the original formula, it's n minus 1. So you get plus 1 minus 1 cancels out. In a way, it makes it easier. So as a problem here, I've got here a problem which has an easy question, then a slightly harder one. Taking a look at it, I'm investing $60,000, 5% interest, compounded monthly. How much will I have in 10 years? So if I actually just kind of go off of that formula we've just talked about, we're looking for the future value in this problem, and the present value is $60,000. What is my rate? It's 5%, so I just leave it as 5. 100 times compounded monthly, so K equals 12. And then up in the exponent, it'd be 12 times 10 years. So my future value would be, and I would just put that into the formula. Easy, easy, easy. Times bracket 1 plus 5 divided by 1200, and then close bracket, raise the exponent of 120 compounding periods. So it'd be 98,820 and 57 cents. Like that. So that's how much I would have. Very nice. Now here's for a slightly more difficult problem. How long will it take to double my money? Maybe I'm looking for something else here. So how do I do that? I do know what my future value is here. In this case, it's going to be $120,000 because that's doubling 60,000. My present value is 60,000. Interest is 5%. 12 is my number of compounding periods per year. And this is 12 times I don't know, because I don't know how many years I'm going to be. So I try to solve for n. So let's start simplifying things. Divide both sides by 60,000. I get this side to be 2. And then I can work out what's in the brackets. So that'll be 1 plus 5 divided by 100. And I made a typo, so that's very annoying. And it's going to be 1.00416666666. So I'm just going to leave like that. 12n is in the exponent. Now you look at this and you're going like, oh, it's one of those problems where the unknown is in the exponent. How do you solve that? Well, remember I just said just kind of memorize this. It's a logarithmic problem, which is the inverse of an exponent, and you take the log of the other side divided by the log of the same side as your exponent, like that. And try not to round off. I believe I've mentioned that before. Log 2 divided by the log of what I had, and it's 166.7016567. Like I said, try not to round off, so n will be equal to, divide that by 12, 13.8918 blah 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 years. That's correct mathematically, but if you want to speak to normal people, that's 13 years and a few months. How many months is 0.8918 of a year? Let's find out by multiplying it by 12, because there's 12 months in a year, and that would be equal to let's see here, 12 times 0.8918, so it'd be 10.7, so let's say 11 months. Always round off because you want to exceed the halfway, the doubling the money. If I round it down, I would come up short. So that's how I would do that one. That's it. Good luck.